Hello, dear students. Welcome to my channel and welcome back to the playlist of basic principles of power system. Uh, if you remember, in previous lecture we have seen star to delta transformation and we have seen the basics of per unit system and percentage method. In order to get the clearer idea of per unit method and percentage method, we will be going through a numerical today, and then we will be going through uh, about the procedure of selecting base values for uh, various quantities. We will be seeing the advantages of power per unit system. So if you have not referred the previous videos in which we have discussed the per unit values, uh, I would recommend you to refer the previous video. The link will be flashing on the I button, right top right corner. And because this lecture, in order to attend this lecture, the understanding of per unit system is prerequisite, so it is mandatory to know about per unit systems and percentage method. So let's start the sum. So what does it say? Is the question is, express the following quantities in per unit form and percentage method for 25 ampere, 0.5 ampere, 1000 volts, 5 ohms, taking base current as 10 ampere and base voltage is 200 volt, and also calculate the base impedance. Okay, so they have provided us with base current and base voltage, and now we have to find the values of base impedance and the base values of per unit values of given voltages and currents. Okay, so just a quick glimpse, what was per unit voltage, what was the formula of per unit voltage? It was nothing but uh, uh, actual voltage divided by base voltage, and similarly the value of per unit current will be actual current divided by base current. Still, let me get you the clearer idea by going back here. Per unit voltage is equal to actual voltage divided by base voltage, and per unit current is equal to actual current divided by base current. Meanwhile, any per unit quantity is the ratio of its actual value and the base value. Okay, so now they have given us the base current as 10 ampere. So we already have the value of base current for 25 ampere line. Let's calculate the per unit value of 25 ampere line. So for 25 amperes, per unit value will be 25 divided by 10, actual current divided by base current. Actual current is at 25 ampere, base is 10 ampere, both have given in the question. So when we take the ratio, we will get the value 2.5. And remember, in the previous class I've mentioned you that while calculating per unit values of various quantities, there will be no unit. They don't have any unit in the end. So what do we write? We write pu, or per unit, 2.5 per unit. Okay, so we write pu in the end. Again, similarly doing it for the 0.5 ampere. So for 0.5 ampere, we have actual current divided by base current. Actual current is 0.5 here, so we wrote here 0.5. Base current is again given 10, so we would write 10. So the base value will be 0.05 per unit, right? Very simple. Now in order to find the percentage of this per unit quantities, per unit current for 25 and zero point 0.5 amperes, what we will do, we will simply multiply this 2.5 with 100 and multiply this 0.05 with 100, or we can multiply 25 by 10 with 100 and zero point 0.5 and by 10 with 100. So what we will get here, we have percentage current is equal to actual current divided by base current into 100. So 25, for 25 ampere, what we will do, we will take 25 by 10 actual current by base current into 100 is equal to 250%. Same for 0.5 ampere, what we will do, 0.5 divided by 10 into 100, right? Actual current divided by base current into 100, so we will get 5%. Or simply you can multiply 2.5 into 100 and you can multiply it 0.05 with 100, you will get the same results, 250% and 5%. So we have find the values of percentage current and per unit current for both 25 ampere and zero point 0.5 amperes. Now coming towards the per unit voltage. So what is the formula of per unit voltage? We have discussed before. It is actual voltage divided by the base voltage. They have already provided us with both actual and base voltage. See in the question, you have to find the per unit form and percentage for 1000 volts. Okay, so your actual value is 1000 volt, and taking base current as 10 ampere and base voltage is 200 volts. So base voltage and actual voltage both are given, so it will be actual voltage divided by base voltage. So actual voltage is 1000 divided by base voltage is 200. So for 1000 volts the per unit value will be 5 per unit or 5 pu. Similarly, if I want to convert this into percentage form, so percentage voltage will be nothing but multiplication of this 5 pu with 100. Okay, so here let's come here. Percentage voltage is equal to actual voltage divided by base voltage and its multiplication with 100. So what will be the value? So the value will be, actual voltage is already given as 1000, base voltage is 200, and multiplying it with 100 we will get 500%. Or simply you can multiply 5 with 5 per unit with 100 and you will get the same results, 500%. Okay, now if you go back to question, they also asked us to find the base impedance. Okay, so and please pay attention, I'm putting emphasis on the word base. Okay, we are not looking for the per unit impedance, we are looking for base impedance. So in order to find the base impedance, what is the formula of base impedance? The formula for base impedance is nothing but the ratio of base voltage by base current. Simple. What is the formula of impedance, you say? The formula of impedance is ratio of voltage and current, simply voltage divided by current. So in order to find the base impedance, what we will do, we will take the ratio of base voltage by base current. Okay, both base voltage and base current are provided to us in the question itself. See, the value of base voltage is 200 volt, value of base current is 10 amperes. So we will take base voltage is equal to 200, base current equal to 10. So 200 divided by 10, you will get the base impedance is equal to 20 per unit. Sorry, that is a mistake. Base, if we are calculating the impedance, then it cannot be uh, per unit. Okay, only uh, values with per unit has pu in behind them. So for base impedance, this is not a per unit impedance, this is base impedance, so the unit of it will be ohm. Okay, so the unit of it will be ohm. It will not be uh, it will not be per unit. Okay, because we are taking ratio of voltage with current. Okay, so it will be ohm. Now coming towards the actual value of impedance is given 5 ohms, and if I want to find the per unit value of this, if I want to find per unit value of this impedance, then we have already found the value of base impedance, right? Base impedance is given, which we have derived, is 20 ohms, and the actual value of the impedance is 5 ohm. So now tell me, if we have to find the value of percentage impedance and the value of per unit impedance, can't we find it by just simply taking the ratio of actual impedance of simply by taking the ratio of actual impedance by the base impedance, right? The actual impedance is 5 ohm and base impedance is 20 ohm. So we are doing exactly that here. For 5 ohms, what we are doing, actual impedance 5 divided by base impedance 20. So by this division, we are getting the value 0.25 per unit. Okay, now again see, I'm telling you, we are taking 0.25 per unit because this is not base impedance, this is per unit impedance, and per unit quantities do not have any unit, so we are writing pu 0.25 per unit. Okay, and in order to find the percentage impedance, we simply multiply this 0.25 per unit with 100 and we will get the percentage impedance. Or we can find it this way: for 5 ohms, what do? We take base impedance, sorry, we take actual impedance, and we divide it with the base impedance. So what is the value of my actual impedance here? It is 5 ohms, and the base impedance is 20 ohms. So we are taking the division of 5 divided by 20, and we are multiplying it with 100, and we are getting 25% as the percentage impedance. Okay, so that was pretty much it for the sum. That's what they have asked us, and that's what we have found all the values. But I'm telling you again, please be very careful while calculating these numericals. Whenever you are having the base values, it will have the unit. Okay, whatever unit it possesses. If it is voltage, then voltage. If it is current, then ampere. If it is impedance, then ohm. But whenever calculating the per unit values or percentage values, for per unit value, it will not have both for both per unit values and percentage values. Both of them will be unitless. But at the end of per unit values, we will write pu, or per unit, and at the end of percentage value, we will write simple percentage. Okay, so they are unitless because it is nothing but ratio of the same ratio of actual quantity by the say ratio of base quantity. The quantity will remain same, so the units will cancel out each other. Okay, so I hope you guys are very clear with the per unit values and percentage method. Now we will be moving forward, and we will see what are the advantages of per unit systems. Okay, so first, as I have mentioned in the previous lecture as well, that the per unit system, it provides the common ground or common base. Okay, all the values, all the values which are present in your system, they all are brought to a common base. Okay, the another example is it simplifies the calculations way too much. Okay, if you see, if you are having the whole system, okay, if you are having whole system, and the system is having uh, so many voltage values, then the calculations gets tricky. But what if we have only per unit values or percentage values? The calculation will get simplified, right? The calculation will be simplified because we are converting it in the per unit values. So you don't have to go with the values like the in let's take one system. There will be voltages with like 33 kV, 66 kV, and then there will also be voltages like 230 voltages, 230 volt. Okay, so how will you deal with all that? So you can convert it with per unit system, in per unit system, and then you can do the calculation. It will be more simplified. Then one more interesting fact, that like if you are having a transformer, so whenever you calculate the per unit reactance values of uh, primary side and secondary side, it will always remain same. Okay, so for transformers, the per unit reactance will always remain same for both primary and secondary sides. So you just have to calculate the per unit reactance of one side, and then you can do the calculations of other side as well, which are connected with the your reactance problems, right? Then another way is, another advantage is, it is very easy and effective comparison on basis of percentage reactances, right? Like in the comparison of basic percentage reactance, it gets very easy, very effective, and especially whenever you have multiple number of machines, multiple transformers, at that time the calculation, it gets very easy with the help of per unit systems. Okay, again, to make it understand in simple words, let's consider your class itself. You are having one class, okay, and in that class you are having 60 students are there in class. Okay, so we can take this class of 60 students as a small power system collected together, and different students can be considered as the different components of power system, like somebody is generator, somebody is transformer, somebody is the transmission line, somebody is something else, something else. Okay, so all these different components are there, and to deal with the calculations of all these different components at once gets very difficult. So what do? We judge their performance on the basis of percentage. That's what we do in the class, right? We judge your performance on the basis of your percentage, whatever you have scored in the exam. So same thing we do with the per unit system. We judge the performances of these different components on the basis of percentage, 100%. Okay, so this will give what does it do? It gives us common base, and it makes the comparison and analysis very simple. The calculations gets very easy. Okay, so those were the advantages of per unit system. Now, uh, quickly coming towards the selection of base values. How do we select the base values? But before we go for the selection of base values, let me tell you something about uh, the base values itself. Like if you want to select the base values, uh, like if you are having a power system, okay, there is a power system, and you are calculating a fall current of something. Okay, you are calculating the fault current of any component. Okay, so at that time you will be dealing with so many quantities. You will be dealing with current, you will be dealing with voltage, you will be dealing with impedance, you will be dealing with reactance, you will be dealing with resistance, you will be dealing with kVA, right? So for the selection of this base value, all these quantities are important, but all these quantities can be derived from two base quantities, which are base kVA and base kV. Okay, so base kVA and base kV are the main quantities, and all the other quantities like base current, base impedance, base reactance, all these can be calculated based on the values of base kVA and base kV. Okay, now let's see what are the guidelines to select the base kVA. Okay, because we have already seen how do we calculate the per unit voltage. So what is kV is nothing but kilovolt, so it is nothing but voltage. So we've already seen how do we take voltage. So now let's see how do we select the base kVA. So pretty much similar how we select the base voltage. We use same formula or same method to select the base kVA. Okay, so first thing what we can do, if you are having a system, you can take the highest rated machine or highest rating of kVA in the system as your base kVA. For example, if I'm having a if I'm having a power system, if I'm having a system, and there are so many transformers which are having different kVA ratings, like one transformer is having 100 kVA, another one is having 250 kVA, next one is having 500, then there is one which is having 300. So we I can take the transformer which is having highest kVA rating, like if among the ratings I've mentioned, 500 kVA is the highest kVA. So you can take that 500 kVA as the base kVA and then perform all the remaining calculations based on that. Similar ways, what is the another method to take base kVA? You can take the summation or addition of all the values of kVA given. Okay, like if I'm saying there is a transformer having 100 kVA, then 150 kVA, then 300 kVA, then 500 kVA, then I can take the summation of all the kVAs. I can add 100 plus 250 plus 300 plus 500, and whatever the sum I will get, let's say I'm getting 150 kVA as the sum of all these values. So I will take 1150 kVA as the base kVA. Okay, because the sum of all these kVA ratings is 1150. Okay, 100 plus 300 plus 500 plus 250 is equal to 1150. So that will be my base kVA. Okay, or for the record you can also take any arbitrary value you want as the base kVA. Okay, like whenever you will be doing the sums of sums related to per unit values, you will see that in so many cases you will take 100 kVA as the base value. Okay, without any explanation, that you can also do that. You can take 100 kVA as base value. Okay, if that makes your that makes your calculations simplified. Okay, so you can do that. Now, after seeing how to select the base kVA, let's see what are the formulas for calculation of short circuit analysis, right? So per unit of kV is nothing but per unit voltage. It is very similar to per unit voltage. It is not similar. It is actually per unit voltage, right? Because kV is nothing but kilovolt, and voltage is similar. Voltage is gonna stay the voltage. It's not going to change, right? So uh, per unit value of kilowatt will be equal to actual kilowatt divided by base kilowatt, or kV, same as voltage because it is voltage. Now if I want to find the value of base current, remember I have mentioned that if you want to find all the remaining parameters, you can derive the value, you can derive the all remaining parameters based on base kVA and base kV. So now we are going to see just that. If I want to find the value of base current, what will be the value? So it will be nothing but the ratio of base kVA with base kV. If you have seen that, if you have seen the numericals related to transformers, we do it a lot. In order to find the value of current, we take the ratio of kVA with voltages. So we are doing the same, but we are by taking the ratio of base kVA by base kV, we are finding base current here. Okay, and again see, uh, as we are finding base current here, so the rating of the unit of the base current will be ampere, because it is a base value, it is not per unit value. Okay, per unit values do not have any uh, units, but base values always have units, so it will be ampere. Now if I want to find the base impedance, as I have already found the base current, how can I find it? So impedance is nothing but the ratio of voltage divided by current. So we are doing just exactly that. In order to find the base impedance, we are taking ratio of base kilovolt divided by base current. So base kV divided by base current, and we are multiplying it with 1000. Now why are we multiplying it with 1000? Because we are pay attention what we are taking here. We are taking base kV here. Okay, we are taking base kV here, and in the denominator we are taking base current. So voltage is divided by current, but here we are having kilovolt, so we are multiplying it with 100. Same ways you can find the base impedance by the division of base kV square divided by base kVA, right? So base kV divided by base kVA, whenever you do, you will find the same value, and again multiplication with 100 with the same reasons. Now you might think there is a square here, so don't we have to multiply with 10,000? No. Why? Because here see, in the numerator we are having base kV square, but denominator we are having base kVA. So there is already a quantity in the kilos present here, which was not in the base impedance, which was not in the formula of base impedance in the previous formula. Okay, and again pay attention that both of these base impedance values and base current values have unit, because these are base values. Base impedance has the unit ohm and base current has the unit ampere. Now coming to another formulas, we are having per unit impedance. If you want to find the per unit impedance, previously we have found base impedance. See, we had base impedance. So now to find per unit impedance, what can we do? We can take the ratio of, first we have to take the multiplication of base kVA into actual impedance divided by base kV square. We have to take the ratio of base kVA into actual impedance divided by base kV square into 1000. Okay, again, see the formula. The previous there was a mistake. I didn't mention 1000 here. I only wrote 1 because I was in hurry. But pay attention again. I have mentioned 1000 here again. So value of per unit impedance is equal to base kVA multiplied with actual impedance divided by base kV square into 1000. Okay, pretty much it is similar to the value of base the per unit impedance, if you remember, right? Similarly, the formula for per unit reactance or percentage reactance, let's call it percentage reactance. It is formula of percentage reactance. If you want to find the value of per unit reactance, then you have to do some minor changes in this formula. Okay, so what is the value of percentage reactance? It is nothing but multiplication of kVA with actual reactance divided by 10 into kV square. Okay, kVA multiplied by actual reactance divided by 10 into kV square. That is the formula of your percentage reactance. Now if you there are some cases, what happens in some cases, you have to change the base value. Okay, you are forced to change the base values. There are some sums. If you go in you go deeper in the numericals, you will see there are some sums in which you have to change the base value. So in such cases, what do we do? The impedance, you have to find it again as per the new base. So per unit impedance referred to the new base, there is a formula for that. What will be the formula for per unit impedance referred to new base will be? So it will be the per unit impedance old impedance multiplied with old base kV divided by base new base kV whole square into new base kVA divided by old base kVA whole square. That will be the formula of per unit impedance, which is referred to a new base whenever you want to uh, change whenever you are required to change the base. Okay, now coming to the short circuit current, what will be the formula? It will be nothing but uh, we will be taking the ratio of uh, the actual current with percentage reactance, and we will simply multiply it with 100. That will be nothing but your short circuit current. Okay, so if you want to solve problems on a short circuit currents, okay, if you want to solve problems for short circuit current calculations in which lines will be fed by generators through the transformers. Okay, such problems, what are the steps to solve them? So let's go through the steps to solve them. So firstly, what we will do, we will develop a single line diagram, and we will put all these values, whatever values we are having, kVA, kV, percentage reactance, percentage impedance, whatever you are having of each component. Okay, so first draw the single line diagram, and in that diagram calculate and put the values of all these percentage impedance, per unit kVA, per unit kV, and put it all them in the single line diagram. After that, we will be taking the suitable base of kVA and kV, and based on that, we will develop a reactance diagram, and we will mention all the percentage impedances, sorry, not impedances, percentage reactances values which we have calculated with the help of base kVA. Then we will locate the fault point, and we will find the whatever the equivalent percentage resistance, percentage reactance will there be to that fault point. Okay, and in the end, what we will do, we will find the short circuit current which will be corresponding to the base kVA that we have selected. Okay, and we will find the short circuit current which will be corresponding to the base kVA which will be which we have selected, and the normal system voltage. Okay, normal system voltage we will be finding. So that was your first chapter, or you can say the basic principles of power system, in order to uh, learn the learn some in-depth topics of power system, you will require to know these concepts before deep you go deep in the power system section or power system department. So we have covered that all. So this was the first chapter as well, and we'll be moving forward with the next chapter in the very next lecture. And till then, I will be seeing you in the next time. Thank you very much for listening patiently. The whole playlist of basic principles of power system ends here, and in the next lecture I will be coming back to you with a very new playlist. I hope you stay tuned for that, and you are also I hope you are also equally excited for that as I am. So that will be this for today from my side. I'll be seeing you in the next lecture. Thank you for listening, everyone. Bye bye, take care.